Friends, today we are going to do some numericals on series and parallel connection. So this is the first numerical for you. As you can see in the diagram, we have a circuit diagram over here where two resistances R1 and R2 are in series. Now why they two are in series? It is because there is only one path for the current to flow. So you may know the formula for the series connection is R is equal to R1 plus R2. Now, in this series connection, we are given R2 equal to 20 ohm. R2 is given 20 ohm. We have to find R1. But we do not know the R. So how can we find the R? Okay. We are given the battery is of 6 volt and the current in the ammeter is 0.25 ampere. So by using Ohm's law, I hope you remember the Ohm's law. Ohm's law is V is equal to IR. Therefore, R is equal to V upon I. Now what is the voltage given here? 6 volt. Is given 6 volt. And the current is given 0.25 ampere or 25 and we take the 100 on the top. So we have 25 ones are 25 fours are 100. So 6 fours are 24. So the total resistance R is 24. So now we can write R 24 equal to R1, which we have to find, plus R2, which is given as 20 ohm. Yes, so what will you get? R1 is equal to 24 minus 20 equal to 4 ohm. So the resistance R1 is 4 ohm. So is the numerical clear to you? We'll go by once again. In the circuit diagram, you have got two resistance R1 and R2 which are in series. How do you know they are in series? Because there is only one path for the current to pass. So the formula for series resistance is R is equal to R1 plus R2. But we don't know what R is, we don't know what R1 is, we only know R2 equal to 20 ohm. Okay? So how do we find the R then? If we take the equivalent resistance of both as R, then we know the Ohm's law, V is equal to IR. So R equal to V upon I equal to 6 upon 25 into 100 gives us 24 ohm. So R is 24 ohm, R1 is unknown, R2 is 20 ohm. So R1 is 24 minus 20 equal to 4 ohm. So in this numerical, the unknown resistance R1 is 4 ohms. Okay. So in this circuit diagram, we have three resistances in parallel. R1, R2, R3 are in parallel. How do you know they are in parallel? They are in parallel because there are three alternate paths for the current to pass. The current can pass through resistance R1 or to resistance R2 or to resistance I3. Since there are more than two paths for the current to pass, the circuit diagram is a parallel connection. So in this equation we are given, in this numerical we are given, R1 is 5 ohm, R2 is 10 ohm, R3 is 30 ohm. Now what we have to find? We have to find the individual current I1 passing through R1, I2 passing through R2, I3 passing through I3. We also have to find the total current I passing through the circuit. Now what we can do here is apply Ohm's law individually. Now what did we learn in a parallel connection? In a parallel connection, the voltage at every point remains the same. Yes, remains constant. If you revise our video on parallel connections, you will find that the voltage at every point, the voltage across every resistor remains constant. So what is the voltage? 12 ohm. So applying Ohm's law, we will have I1 equal to V upon R1 equal to 12 upon 5 equal to 2.4 ampere. Similarly, I2 equal to V upon R2 equal to 12 upon 10 equal to 1.2 ampere, and I3 equal to V upon R3 equal to 12 upon 30 equal to 0.4 ampere. So I1 is 2.4 ampere. Can you see this? The resistance is less, so the current is more. As the resistance increasing, the current is decreasing. And when the resistance becomes maximum, the current has decreased to 0.4 ampere. Now the total current passing to the circuit in a parallel connection I equal to I1 plus I2 plus I3, that is 2.4 plus 1.2 plus 0.4 or 4 ampere. So the total current passing to the circuit is 4 ampere. Okay, I hope you are clear till here. Now we will find out the equivalent resistance of the whole circuit. Okay, so I hope you know which formula we use. Now let us find the equivalent resistance. So for a parallel connection, what is the formula? The reciprocal of the resistance equal to sum of reciprocal of individual resistances. So we have 1 upon 5 plus 1 upon 10 plus 1 upon 30 equal to, how will we solve it? We will look at the LCM. What is the LCM of 5, 10 and 30? It's 30. So we have 6 upon 30 plus 3 upon 30 plus 1 upon 30 equal to 10 upon 30 equal to 1 upon 3. So we have 1 upon R. So we have 1 upon R equal to 1 upon 3. Taking the reciprocals, R is equal to 3 ohm. So the equivalent resistance of the three resistance in parallel is 3 ohms. Now let us check one more thing, just for verification. The total resistance, equivalent resistance is 3 ohm. The current we had is 4 ohm. The voltage is 12. Ohm's law, V is equal to IR. Just for verification, I is 4, R is 3. 4 3s are 12, which is our answer. So in this numerical, we have seen the diagram. We found out the current passing through each resistor. We found out the total current passing through the circuit, and we also found out the equivalent resistance of the circuit. So this is a diagram based numerical. When the diagram is given to you, you have to first figure out whether the figure is in series or in parallel. It can be a combination of series and parallel. So according to the diagram, you have to work out the numerical. Okay, in this numerical now, we are given only a part of the circuit. If you can see the points A and B, we have got one resistance of 1.5 ohm, another resistance of 4.5 ohm, and a third resistance of 6 ohm. What we are supposed to do here is find out the equivalent resistance of the circuit. Now, if you see 1.5 ohm and 4.5 ohm are in the series. Why they are in series? Because between those two there is only one path for the current to flow. So if you look at the diagram, 1.5 ohm and 4.5 ohm are in series. They are in series because there is only one path for the current to flow. So let me find out the equivalent resistance of these two first. Because they are in series, I can say the first part R1 is 1.5 ohm plus 4.5 ohm, which gives me 6 ohm. So this part of the circuit now has got 6 ohm resistance. So this total is 6 ohm now, and this is also 6 ohm. Now these two are in parallel. Why they are in parallel? Because there is one path for the current to pass and there is another path for the current to pass. So now these two are in parallel. So for parallel connection we have 1 upon R equal to 1 upon 6 plus 1 upon 6 is 2 upon 6 or 1 upon 3, which implies 1 upon R equal to 1 upon 3, therefore R equal to 3 ohm. So the equivalent resistance of this whole circuit is 3 ohm. Now what I am going to do next is attach a battery to the circuit and we'll find out the individual current and the individual voltage passing through the circuit. Okay, what I've done now, what change can you see? I attached a battery of 24 volt to this circuit. Now what I want to do, I want to find out the current passing through each and every resistor and also passing through. Okay, now I have attached a battery of 24 volt. Now this path and this path both are in parallel, and we have seen in a parallel connection the voltage remains constant at both stages. So here the current passing to this path, I will call it I1. So I1 will be V upon R. Since the voltage at both the paths remains constant, it is 24 volt and the resistance is 6 ohm. So we have 4 ampere. So the current passing through this path is 4 ampere. Okay. So this is the current passing through this path. Now here we had a total of 6 ohm. So again by 6 ohm, the total current passing here is also 4 ampere. Because both the equivalent resistances are the same, the current will also remain the same. But the current passing through both this will be different. Why it will be different? You will see for yourself. What happens now? The current is divided because in a series connection, the current changes, the voltage remains constant. So now we'll try to work out the voltage in both the paths. Okay? So sorry, but this is a series connection, so the voltage will be differ, but the current will remain the same. The current passing through both the resistance is now 4 ohm, because in a series connection, only take this part now. In the series connection, the current remains the same, but the voltage changes. Okay, so this 24 volt is at these 2 points. Now we have to find out how much voltage across this resistor and how much voltage across this resistor. So again we have to use which law? Ohm's law. What is Ohm's law? V equal to IR. So V1 passing through here will be 4 into 1.5 equal to 6 volt, and V2 equal to 4 into 4.5 equal to 18 volt. So the potential difference between this resistor is 6 volt and between this is 18 volt. 18 plus 6 is 24, which is the voltage passing through here. Now this may look slightly complicated to you, but you have to work it out. Yes, you can see the video again and let me explain you one more time. This diagram has become little complicated, but still we'll try to make it simpler. What did you have at the start? So actually this is what we had at the start. We had a part of a circuit diagram having 3 resistors, where the 2 resistors are in series and those 2 resistors in series are in parallel with the third resistor. So you have seen from the start that this circuit diagram is a complex diagram. It's a mixed diagram having 2 resistors in series, and those 2 in series are in parallel with the third one, which was given to be 6 ohms. So what I individually did first, if you rewind the video and see, we first found out the equivalent resistance of this whole, which we got 3 ohms. That is the equivalent resistance. And then I attached a battery of 24 volt. I found out 24 volt. Now since both are in parallel, the potential is 24 volt for the top path also and 24 volt for the bottom path. So in the top path and the bottom part, the voltage 24 remained the same. Now In a series connection, the current remains the same, but the potential volt is different. So what I did, I found out the individual potential, where I got this as 6 volt and this as 18 volt. 6 and 18 is 24, which was passing through the top line. So this is a combination of series and parallel connection. We'll do a few numericals more, so you'll get a concrete idea. Okay, look at the circuit diagrams now. Both the circuit diagrams may look same to you because both are in the shape of a square. But what is the difference here is the path through which the current enters and through which the current exits. So here it is entering from this path and exiting from here, and in this case it enters from here and exits from here. So in both the cases we have different paths for series and different paths for parallel. So let us see. When the current enters from here, this is one path for the current to flow out, and this is another path for the current to flow out. So this and this are in parallel. Okay? Observe. The current enters from here and this is one path. The current enters from here, this is second path. But here there is only one path. So this two resistances have to be in series because between them there is only one path. So we have R1 equal to resistance C plus resistance D, and this R2 equal to resistance A plus resistance B. I hope you follow. This is C and this is D. Now between C and D there is only one path for current to follow, so they are in series. Between A and B there is only one path for the current to follow, so that are also in series. So we have 3.5 plus 8.5 equal to 12 ohm, and here 0.5 plus 2.5 equal to 3 ohm. So the equivalent of this resistance is 12 ohm and the equivalent of this resistance is 3 ohm. Now 12 and 3 ohm are in parallel because they make two separate paths. So the resistance of the circuit in parallel we write as 1 upon R equal to 1 upon 12 plus 1 upon 3. The LCM of 12 and 3 is 12. So 3 4s are, we have 12. So we get 1 upon 12 plus 4 upon 12 equal to 5 upon 12. So 1 upon R is 5 upon 12, implies R is equal to 12 upon 5 or 2.4 ohms. So the equivalent of this circuit, yes, 4 resistors are there, this two in series, this two in series, and overall both of them in parallel. The equivalent resistance we get is 2.4 ohm. Okay, now we'll move to the next case. In this case, the current comes in from here and moves out from here. So this is one path A through which the current can pass, and this is the second path through which the current can enter and pass. But if you see, the current when it enters from here, there is only one path for the current to pass. So R1 is B, C and D in series. So it's B, C and D in series. So we have 7 plus 9 plus 8. That is 24 ohms. And there is only one path for the current to pass through A. So R2 is only A, that is 6 ohm. Now the equivalent one path and two path are in parallel. So again 1 upon R equal to 1 upon 6 plus 1 upon 24. The LCM of 6 and 24 is 24. 6 4s are 24. So we have got 4 plus 1 upon 24 equal to, we have to be 4 plus 1 upon 24 equal to 5 upon 24. Now 1 upon R is 5 upon 24. So R equal to 24 upon 5 equal to 4.8 ohm. So if you observe here, then you will see that in both the diagrams we had a square pattern only. But from where the current enters and from where the current exits will determine which resistances are in series and which resistances are in parallel, it's a combination of both series and parallel. So again, the current is entering from here, this point, and exiting from this point. So these two resistance are in series and these two resistance are in series, and overall both the resistance are in parallel. Here the current enters from here, flows through this path. So this is only one resistance, while this three are in series because there is only one path for the current to flow. But these two will make a parallel connection. So look, you can look at this diagram and see that even though the figures look the same, what depends is from which path the current enters and from which path the current exits will determine which resistors are in series and which resistors are in parallel. This is a very good example, so kindly go through this one more time. Here is another diagram. We have got four resistors here, 4 ohm, 5 ohm, 2 ohm and 2 ohm between the points A and B. Now we have to find the equivalent resistance of this circuit. So again you can watch here, the current coming from A passes through 4, only one path, passes through 5. So till here the current has only got one path to follow. But here the current can pass through path 1 or the current can pass to path 2. So here we have two paths for the current to flow. So these two resistances are in parallel. So let us first solve this parallel. Let me call the parallel resistance R prime. So R prime is 1 upon 2 plus 1 upon 2 equal to 2 upon 2 equal to 1. So 1 upon R prime is equal to 1. Testing the reciprocal, R prime is also equal to 1. So what did you observe here? The combination of these two gives us a resistance of 1 ohm. Okay? So these two resistances 2 ohm and 2 ohm in parallel gives me an equivalent resistance of 1 ohm. So now I can rub this both so that you can see I have put the equivalent resistance in its place. And now these three resistances are in series. So the R will be now 4 plus 5 plus 1 equal to 10 ohm. So the equivalent resistance between point A and B is 10 ohm. So what is the 1 ohm I place here again? Actually there was no 1 ohm over here. Actually we had two resistances of 2 ohm in parallel, which gave us an equivalent resistance of 1 ohm. So the whole equivalent resistance of this is 1 ohm. So 1 plus 5 plus 4 gives us 10 ohm. I hope this is clear to you.